Hey, so in this lesson, I'm going to teach you the whole topic of conic sections. But before I do, I'm going to run you through all the fundamentals and the basic things, and just show you how the formulas are derived. That should they switch the questions, you'll not be doomed. Okay, everything will be good. So the interesting shapes under this topic are an ellipse, a circle, a parabola, an ellipse, and hyperbola. So I'm going to start with a circle and move in that order. So uh those are the shapes, those are the conic sections. Now, why are they called conic sections? As you may see, we're talking about you having maybe a cone, okay, and then cutting it in a specific orientation, and then that section will form a specific shape. So that shape can either be a circle, that's if you cut it straight, an ellipse if you just tilt the cut a little bit, a parabola if you cut it in this manner, and a hyperbola if you cut it in that manner. So let's start with a circle. Okay, so let me start with this important thing that you need to know, because you're going to apply it when pretty much deriving any equation. Yeah, so assuming you've got one point here, and then you've got another point here, okay, and then you want to find the distance equation between these 2 points. Okay, so the distance between these points here is maybe given by r or d, whatever it is you can put. So assuming this here is on the xy plane, okay, say this here is the x-axis, this here is the y-axis. So it is this here is located at some point x comma y, then this as well is also located at some point x comma y. So to write down the distance equation specifically for r, okay, it is going to be r is equals to, you open brackets, and then you say x2 minus x1 close bracket squared plus open bracket y2 minus y1 squared, okay, where x2 will be this and y2 will be this, x1 will be this, and y1 will be that. So having done that, so yeah, this is just some important thing that you have to understand while driving, okay, equations under conic section excuse me, conic sections. So let's talk about the circle. So this is your circle, okay, obviously you know what a circle has obviously you know how a circle has to look like. So this is your circle, okay, and then we've got some point of interest here and another point of interest here, okay. So this, as we may see, is located at the origin. So the coordinates for this point will be x comma y, which is just 0 comma 0, since of course it's the origin. Then the coordinates for this will be some point x comma y, okay. So again, because this point here is on the circumference of the circle, or the circumference on the surface of the conic section, so this here will be our r2. So to find the distance between these two, we can just use the same approach which we did previously. So that is to find the equation of a circle under conic sections. So it is going to be r, that is to say the distance or the radius in this case, since it's a circle, r is equals to, you open brackets, then you say x2, that is to say this, x2 minus x1 squared plus y2 minus y1 close bracket squared. So that is a distance equation between these two. So now let's just substitute and simplify. So this will be r is equals to, as we may see, our x2 here is of course just x2, but then our x1 is 0 since it's located at the origin. So it will be minus 0, we close bracket, and we say plus y2, which is this, y2 minus y1, which is also 0 because it's located at the origin. Let's not forget the squares there. And then when we simplify further, it is going to be x2 squared plus y2 squared. And then let's let's remove this here, okay, by multiplying, by adding a square both sides. So that would be squared and that would be a squared, so that will cancel out with this, and what we're going to remain with is r squared is equals to x squared plus y squared. So this here is the distance equation, sorry, this here is the equation of a circle under conic sections. Of course we would have used of course this just looks like the Pythagoras theorem, because the distance equation here, you got x, here you got y, and you want to find what r is by saying r squared, but we don't want to memorize, we want to understand where everything is coming from. So with a circle, that is that. Let me see. So yeah, with a circle, we're done. That is that. Then we can just move on to the equation of a parabola. So this is the equation of a circle under conic sections. Okay, so now let's move on to something different, and that is to say a parabola. Parabola. Yeah, I think the pronunciation depends on the structure of your mouth. So if you've got let's see, this is your x. Yeah, so this is your x or your xy plane, and then you've got another one here, and then you have another one here. So let me just run you through the orientation of a parabola and just aid you in what it would look like. So in this case, the parabola can look like this, it can look like that, it can look like that, it can have different orientations. But one thing we need to know about the parabola is that with it, there's always going to be what is known as a foci or focus. So, that is a very critical point under conic sections. This point, I'll explain more of it when we begin to talk about applications of conic sections. But let me just give you a brief overview of this same foci. Okay, so if you've got your parabola that looks like this, okay, then this is a foci. This point plays a very critical role. Okay, it has to be calculated. If you've got, say, so this is a foci of this parabola. If you've got, maybe this is made out of glass, or not glass, aluminium foil, anything that could actually reflect light or heat. Okay, if heat coming from the sun, okay, hits any surface on this parabola, it is going to bounce. No matter where it hits, it is going to bounce, and then all the heat will reflect on this point. So this will be the hottest point. Okay, in the same way, when heat is coming from this foci, okay, it will bounce all around, and then it will come out in a way that it goes in all directions. That is why maybe when you've got a flashlight, it has excuse me, the flashlight looks like, a torch, a typical torch looks like a parabola. Okay, and then you've got the foci. So that foci was actually calculated so that when light hits this surface here, it will actually bounce around, and then when it comes out, it goes in all directions. In a similar way, if the light was to come back, it would come and hit any surface, and then would hit on the foci, and that is a point of interest. So that's just a brief overview of applications of conic sections. Now, before I even talk about before I even carry on, let me just give one more example. So talk about those maybe DSTV type of dish. I don't know what you call them in your country, but in mine, we call them a dish. Okay, so those things are usually found on top of your roof, and they usually look like this. Okay, they usually look like this, with something sticking out like that, and then like so. Yeah, so this is a foci. It is the point of interest. Okay, this point, so if maybe from a tower, okay, that is having some signals coming out like that, these signals, whenever they hit this surface of a parabola, the surface will reflect those signals to the foci, and that is the point of interest. And this part here will receive most signals. So I hope you've just gotten an overview of what the foci is. It is, of course, a point of interest which has to be calculated, where if anything, it may be sound, whatever it is going to receive the most. Okay, it is going to reflect from the surface of the parabola to the foci. So having said that, okay, this is our sorry so this here is our xy plane, and then our parabola looks like this. What do you think would be the coordinates of the foci? So the coordinates of the foci will be p, some random number, sorry. So the coordinates of the foci will be some random number p, or x comma 0, okay? It will be x comma 0. But in this case, let's just use p, the letter p. That will come later on as an explanation. So it will be p comma 0. So this would be where the foci would be. So, but what if your your parabola is oriented like so? What do you think would be the coordinates of the foci? So the foci would be at some point p, not p, sorry, it would be 0, comma, y. And that y would be the same p, that is to say, the foci, somewhere here, some point from the origin. Because we're saying x, comma, y. So in this case, it is 0 in the x and some point p in the y. So that is where the foci is. Then, what if, so let me just draw this one nicely. So, what if your parabola is oriented like so? Okay, where do you think the foci will be? So I know the pause the video type of thing is not mine, someone else's, but just do the needful and try guessing. So the foci here will be negative p, that is to say x comma y, negative p comma 0. Why are we saying 0? Because it's 0 in the y. Okay, then what if, okay, it is oriented like so? Where would the foci be? So the foci will be here. Okay, yeah, so I think you get the idea. And of course the coordinates for this will be, for x, that would be 0, because it's just 0 in the x, but for y it would be negative p. So the foci in this case is negative p. I believe you get the idea. Okay, so let's just move on. So you're going to learn about okay, yeah, so the equation of a parabola will depend on the orientation, on its orientation. Okay, it can either be as discussed here, with the first diagram, the second, or even the third, the fourth, whichever. It all depends upon its orientation. So how do we even come up with these formulas? Okay, so here's the idea. Okay, this, let me just start with let's see. So here's the idea. Okay, so this is your x or y plane, and then this here is your parabola. So this point, okay, where it starts from, not necessarily the origin, but where it starts from. So if this here is your parabola, then this is the point I'm talking about. So this point is known as the vertex. Okay, and then the foci, of course, we discussed this already. It is located here at some point P. And then one thing you need to understand about this parabola is that there's a specific distance that we're interested in. Of course, we've talked about the foci, which is the distance from the vertex to, of course, where this is. Okay, that is to say, that is the first distance. Then the other distance we're interested in is the opposite of the foci. So this here would be negative p. So if the distance from here to here was 5, then the distance from here to here would be negative 5. So this negative p here is the directrix. So this vertex, this foci, this is a directrix. So if your conic section, let me just go back to those diagrams. So in this case, the foci is located here. Then the directrix will be located here. Then as for this one, because the foci is located here, the directrix will be located down there. In a similar way, this here is the foci, this here is the directrix. In a similar way, I believe you get the idea. Okay, so that is a yeah, you know what I mean. So the distance from here to here is the same as the distance from here to here. Okay, then and one more thing. So yeah, I think I've said enough about that. I just hope you're just writing down some notes somewhere. And then another interesting thing is this. Okay, let me just draw the xy plane again, and then this here is your parabola. Okay, if your foci is maybe from here to here, so this is a vertex down here at the origin, and then this here is your foci at some point P. If the distance here is 2, then the distance from here to here, it is 2 times 2. So if the distance, let me just say that again, maybe if the distance is 5 from the foci, sorry, from the vertex to the foci, then the distance from the foci straight to the surface of this parabola, it is going to be 2 times 5. That would be the distance. So in other words, this here is at this foci here is at some distance p in the y. So meaning from here to here, this would be 2p. So in a similar way on the other side, the distance from here to here, it is just what? It's a p. Then this here is twice that distance from the vertex to the foci. So that would be 2p as well. Then, so that's another thing to take note of. I'll do a quick summary over that. And then another thing is this. What else? Yeah, so the directrix is located here. So another thing you need to understand, okay, with a formula, because of, I don't want the video to be too long. So with the formulas and driving, I'll start doing it in the next video. But as for this one, I want us to understand I want us to get the concepts between these things, also about these things, so that should they switch questions or anything, you'll be able to understand and know how to go about it. So the distance, another thing you need to know is the distance from the foci to the surface of our conic section, which is the parabola, is the same distance as from this surface to the directrix. Believe it or not. But anyway, I know this sounds like physics, where you have to have projectile motion. Someone throws a ball, and then you're being told saying that the same time it will take for someone to drop one is the same time it will take for this one to go. I know, looks like it's hard to believe, looks like it's not the case, but that's actually the case. But anyway, the distance from here to here is the same distance as from here to here. Okay, so I believe I've explained pretty much everything that is needed to be understood under this, and then in the next video I'll begin to derive some formulas. Oh, another thing, just a name. Okay, this distance here, this one right here, is just known as the latus rectum. Excuse me. So in summary, let me just give you a summary of everything I've explained so far before we begin to derive our equations. This here is your parabola. Okay, currently it is located where? At the origin. So that is at 0 is equals to 0, and this origin is known as the vertex. The foci is always located inside the parabola. Okay, so this foci here would be x comma y, so that's some point x, so that's some point p. In the y it is 0, so that's p comma 0, which is just our p. Okay, this is a foci. The directrix is the same distance as the vertex to the foci. So the same distance we have from the vertex to the foci is the same distance as we have from the vertex to the directrix. So our directrix will be somewhere here. So if this here is the distance of 10, then this here will be the distance of negative 10. And then if this here is 5, if this here is 5, okay, then this would be 2 times 5. That is how wide this parabola would be. Then on the other side it is the same thing. This would be 2 times 5. Then lastly, the distance from the foci here, let me just use a different color. The distance from the foci to the parabola is the same distance as excuse me, as the is the same distance when we move from the parabola to the directrix. So that's it. So that's that. Okay, so let me just pick it up from where we ended. So let's begin to derive those equations now that we've gotten the concepts between a circle and a parabola. So with a circle we derive the equation already. With a parabola, let's get right to it. So like I said, the equations will depend on the orientation of the parabola. Okay, but it's also complicated. It's actually very easy. So this here is your, hold on, yeah, so this here is your xy plane. Okay, and then this is your parabola, which is located at the origin. Okay, now remember, where is the foci located? At some point p, 0 comma p. Okay, so that would be 0 comma p. Okay, that is where the foci is located. Then remember what we discussed last time. The distance from the foci to some point here on the vertex is the same, on the parabola, is the same distance as from here all the way down to the directrix, which is located at the bottom there. So we need to understand, saying this here, this point has got some coordinates x comma y, since it's located up there, somewhere up there, just somewhere here. Okay, then the directrix also has its coordinates. Okay, it is located x, some point x, which is the same as the one at the top, since they are both in the same x-axis, comma negative p. Now why am I saying negative p? As a matter of fact, this here is supposed to be dotted. Let me just rub it out. Yeah, so let me just have it dotted to avoid confusion. Yeah, so this directrix here is located, rather this point here on the directrix is located at some point negative p in the y. Remember, the distance from here to here is p, meaning the distance from here to here will be negative p, since the distance is the same. So this will be negative p. Okay, so with this, let us now go back to that distance equation which we're talking about, but this time we'll say this distance is equal to this distance. So let's just name this. So this here is a foci, this is some random point v in the some random point v. Okay, that is part of the surface of this parabola. Then this here is a directrix D. So we'll say FV, the distance between F and V, is the same as the distance between what? V and D. Okay. With that being said, now let us come up with this equation, okay, which we are looking for. Let's first start with the distance between F and V. F has got the coordinates 0, P, and Y, so and V has got the coordinates X, Y. As you may see in this case, V is the common one. It is the one that we're going to have as our Y2 and X2. So let us first find the distance equation between F and V. So that would be, so the distance equation would be X2, which is X, minus X1, which is 0, then you say squared, plus Y2, which is just Y. Y2 will be this. And as you may see, this Y2 here is, this Y2 and X2 here is our interest, because it lies in the surface of this conic section. So that would be Y2 minus, what is our Y1? Come on, what is our P? Okay, and we say squared. This should be equal to, now let us write down the distance equation between V and D. This V here and D. So that would be the distance from V to D. Okay, so let's first write down their coordinates. So the coordinates of V are, so let me just write down the coordinates here. The coordinates of V, it is X, Y, and the coordinates of D, it is X, negative P. Okay, so writing down the distance equation between these two, that would be the square root of X2 minus X1. Now this X2 and X1 are literally just the same, because these lie in the same x-axis. So from here to here, this X here is the same as from here to here. Okay, so X2 is the same as X1, so that will just be X minus X, which will be 0. So squared plus Y2, in this case it will just be a Y. This Y here is what we're considering right here. Okay, because this Y is the Y2, what that we're going to use, and it is lying in the circumference of, not in the circumference, on the surface of this parabola. So Y2 minus Y1, which is negative P squared. This negative P, of course, is just this here. So let's simplify. Okay, let's start with the left hand side. So this will be X squared plus Y minus P squared should be equal to, so this would be X minus X, which should just be a 0. Then we say open brackets 0 plus, or you may not just write it down since it's not important. Then this would be positive plus positive here, that would be, sorry, negative plus negative, that would give us a positive, so that would be Y plus P, so that would be a squared. So let's simplify it further by removing these here. How can we remove this? We just introduce the square both sides, so that would be squared. We do the same this side, squared. So this goes, that goes, this goes, that goes. What we're going to remain with here is X squared plus Y minus P squared should be equal to, we say Y plus P squared. Okay, now let's expand these, okay, which are in brackets. So to expand these, we're going to have X X squared, okay, plus, so this will be Y squared minus 2py plus p squared. Now, for those who may be wondering how I expanded this, it's just a simpler method. So this here is y minus squared, y minus p raised to the squared. So this here is the same as y minus p times y minus p, okay? Of which, when simplifying, this will be y times y, it is going to be y squared. Then y times p, it is going to be, y times negative p, it is going to be negative py, okay? Then here this will be negative p times y, it is going to be negative py. Then negative p times negative p, it will be positive p squared. So this here is more like negative 2 minus 2, which will just be negative 4. So this here will be a y squared minus 2py plus p squared. So it's just a simpler way of simplifying. Anyway, so we simplify it there. So it's just a simpler way of doing things. So we do the same this side. So this will be y squared plus 2py. So the first one you say y squared, okay? Then the second term, okay, you're just going to say 2 times the combination of these two, which is 2py. Then lastly, you're going to say plus py, p squared, okay? So this is what we have. So let's simplify it even further, okay? As you may see, we can now just start cancelling out what is common. Excuse me, what is common. So in this case, p here is common and p here is common. So we're going to remove that. So the p will go and p will go. What else will go? Y will go, y will go. So what will remain with here is x squared, okay, minus 2py should be equal to py. So we can't cancel these out because they're not the same. This one has a negative, the other has a positive. So let's take this one to the other side. Of course, we don't take it to the other side. We add both sides by negative 2py. They may cancel out. So, but to simplify things, let's say it jumps. So this would be x squared is equals to 2py plus, because the sign will change, 2py, okay? So this here will be x squared is equals to 2py plus 2py. That will be 4py. So colleagues, we're done. This here is our equation for a parabola whose orientation is like this. So the same can be done. I highly advise you to try this out. Let me just do one more, but the orientation will be different, okay? So these are the equations. So there's x squared. X squared is equals to negative 4py. This is the case if the parabola is oriented like so. And then the other two equations are just y squared is equals to 4px. Then the other one, this is in the case where your parabola is oriented like so. Then the other one is y squared is equals to negative 4py. This is the case if the parabola is oriented like that. So in the negative x-axis. So that is that. Thanks for watching. I just hope you've understood how we're coming up with these equations. So you can just try this out, try coming up with the equations for these. I don't know if I should just try it one more time. It would be a waste of time. But anyway, so that is the idea. That's how these formulas come about. So remember, P is where the foci is located. Okay? Then this X is that point of interest. Sorry, this Y is the point of interest. Because not really the point of it, but it is the point on the surface of the parabola. then the x is also that same point on the surface of the parabola. So we'll just look at some examples of this. Tell you what, let's just look at those examples right now. Okay, so let's move on by looking at some examples. So okay, let's look at this example. This example says find the equation in standard form of a parabola whose vertex is at the origin and focus is at -2, 0. That's everything about the question. It says find the equation in standard form of the parabola with vertex at the origin and focus at -2, 0. So this here is your xy plane, and then all that you've been told is that the vertex is here. Okay, so we don't know now if it's located, if it is oriented like so, like so, like so, or like that, but all that we know is that the vertex is there. Then now what we know, or rather what we've been told, is that the foci is located where? -2 in the x and 0 in the y. So that's -2, 0. So somewhere here. This obviously will have to tell us saying that, okay, it will open like this. Now the thing is, we don't know. Oh, then let's also graph it. Now we don't know how wide it is. It can be like this, it can be like this, it can be like that. We don't know how wide it is. It can be very wide, but not very wide. But remember, how can we know? Remember what we discussed previously. This here is your origin, then this here is your foci. So your focus. So if the distance here is 2, then the distance from here to the surface of the parabola will be 2 times this distance. So that would be 2 times 2. So if the distance here was 5, okay, from here to here, if the distance was 5, then the distance here will be 2 times 5, which is 10, and then the same goes for this side, which would be 2 times 5, which is 10. So it would look like so. Okay, yeah, it would look like that. So this would be a 10, this would be a 10. If the distance here was 6, so this would be 2 times 6, which is 12. So this, if the distance from here to here is 6, that would be 2 times 6, which is as a 12. So from here to here, we just count 12 units up and 12 units down. So it would open up like that. But anyway, we've been told to find the equation in standard form of the parabola. So we need to find that equation, okay? The same equation which we had to derive, but in this case, for the parabola whose orientation is this way, okay? How do we go about this? So we know, always write down the standard equation first, okay? So the standard equation in this case, yeah, we need to remember the standard equations. I know some of you may forget because obviously you not have to you not have to always derive it. So I discussed this in the previous lesson, saying that is when we're deriving the equation. So this here, there's x squared is equals to 4py. There's x squared is equals to -4py. There's x squared is equals to there's y squared. There's y squared is equals to 4px, and there's y squared is equals to -4px. Okay, so the best way, I know it's a weird one, but the best way personally I've memorized these equations, and for which one specifically, is thinking of it as a person. Okay, if this is a person, okay, with little smile and eyes right there, his hands would be like so. Okay, so if this is the head, which is in the x, so that would be x squared, then the parabola would either open like so or like so. Just depends if it has a negative or a positive. Okay, now if this person's head is here, and then the arms obviously will be this side and this side. So meaning if the head is y squared, then this would be y squared is equals to 4px. It would either open in this way or that way. In this case, our parabola is opening which way? It is opening this way. Okay. For that reason, this is the arm on one side. We need to understand saying that, okay, then the head is this side, meaning the y, this would be y squared. Because as we may see, this x squared, this is y but not squared. This here is y squared, this is x but it is not squared. So, yeah, so that would be y squared. Yeah, so that would be y squared is equals to 4px. Okay, this is our equation, but this is not completely correct. Why? Because this which I've written is if the parabola is opening this way, but in this case the parabola is opening in towards the negative side, so this would be y squared is equals to negative 4px. This is a standard equation. Okay, then we want to write down specifically, so always write down the standard equation and then refer it to what you have. Okay, how am I going to make use of this? So what do we have? We've been told saying that the foci is located where? At some point negative 2 comma 0 in this question. Okay, so it is going to be, so this p is located where? At negative 2 comma 0. Okay, so it is where there's x. So yeah, where there's p, remember what we discussed previously? We said we drew this diagram and then I did this, and then I was asking you what are the coordinates of the foci. In this case, this would be x, which is p comma 0. Okay, so this p here is where the foci is, so the p is equivalent to the foci. So in this case, the p is located at negative 2 here, right here. It's located at negative 2, so that is our p. So p is equals to negative 2 in this case. So it is going to be y squared is equals to negative 4, then times 2, then x. Okay, so it is going to be y squared is equals to, what is our 4? Or so 4 times 2. So negative 4 times 2, that would be negative 8x. Okay, so we are done. This is our answer. This is the equation that describes this parabola. Moving on to a different question. Let's make things interesting. I just want us to understand another question. Okay, find the length of the latus rectum of the parabola. Okay, remember what we discussed last time? If this here is your parabola, the latus rectum will be that line right there. So to find the length, so find the length of the latus rectum of the parabola that has the equation x, let me just zoom in a little bit, that has the equation x x squared is equals to 4py. Okay, find the length of the latus rectum. Now it's usually easy for us to do these things, especially when we draw this x or y plane. So in this case, let us draw it first. Now this here is x squared, so which one is the squared? Is it the y or the x? So obviously it is the x. Okay, so meaning the head is this side. I know it's a weird one, but it's up to you if you go with it or not. Okay, now this here is the x squared, this here is the head, so meaning it's a person's arms will be on the sides. Okay, so meaning to either open like that, or like this. Now it's up to you. Now as you may see, this here is a positive value, so meaning it is opening like so. So it will look like this. Now thing is, we don't know just how long this is. Okay, Okay, so let us do some practice questions. But before we do, I'd like us to just take a good look at these images. Okay, so let me just zoom in at the first one. So as you may see, with the first, it's more like what is this? It's a telescope. Okay, whatever it is. The point is, light would come from whatever direction it can come from. When it hits the surface of the parabola, it will reflect, and then that light, okay, whatever it is, it can be rays, it can be waves, it can be sound, it is going to hit the surface of the parabola, and then that surface will all be focused on the foci. Okay, so using this same knowledge, a student at Mulungushi University even won this must be science fair or engineering, something like that, just recently. Okay, this same 2025, he won because he applied the same knowledge under conic sections to create a small device that can help you heat water. Okay, he had to get mirrors and then had to create a small parabola, and when he did, he had to find where the foci was, and when he did, that's where he had to put his container. So light and heat was coming in all directions, and whenever it hit the surface of the parabola, it would reflect, and then it would all be focused on the focus. Focused on the focus. But anyway, yeah, it would all be focused on the focus, and then that cane, which he painted black, would heat up. Okay, so you'd be having warm water without needing electricity because all the light would be focused on one point. So yeah, the same goes for this. So this here is a flashlight. As you may see, it has been put somewhere, right? It's just somewhere there. So that point here, there is a foci. Remember, it's not just about the light that is entering, hitting the surface of the parabola and then coming on the light bulb, but also light coming out of the light bulb, hitting the surface of the parabola and going in all directions. Okay, so the same goes for satellite dishes and whatnot. So let's look at another example of conic sections. Okay, so we're told saying that a searchlight has a parabolic reflector that forms a bow. Okay, a searchlight has a parabolic reflector that forms a bow which is 12 inches wide from rim to rim and 8 inches deep as shown in the figure. Okay, if the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? So basically what they've told us here is this. Okay, so this here is your dish. Okay, and then the foci is here. Then of course it's a light bulb. Okay, now we don't know the distance from the vertex. Remember, the vertex is always here. From the vertex to the foci, we don't know what the distance is. But one thing we know for sure is from here, this dish, rather this reflector, is 8 inches deep, and then it is 12 inches wide. Okay, 12 inches wide. Now some of you may be guessing, saying no, we just cut this in half, so this here will be a 2, and we know, saying that the distance from the vertex to the foci, okay, is just once it is just half the distance as the foci to the surface of the conic sections. Yes, that is true, but we can't apply it here because the foci is not located here. We would have done that, would have said, yeah, let's cut that in half. We'll have a 6 here, and then we say 6 divided by 2, that would be a 3, and that 3 here, this 3 here, oh sorry, and that 3 would be the distance from the vertex to that foci, which is here. But we can't apply that. Okay, why? Because the foci, sorry, the focus is not located where? Here. I hope you got that. So yeah, it is true, it is very applicable. If surely the foci was located there at the top, then this is a distance of 2 or 5, I don't know. This here would be 5 times 2, which is 10, another 5 times 2, which is 10. Then it would look like this. But in this case, it is located down there, so we want to find the distance from the vertex to the foci. What is that distance given this limited information? Now let us look at this parabola. Okay, what orientation is this? Like I said, it always becomes easy when we like draw it out. So this, excuse me, so this has the orientation of this. Okay, now for that reason we know, saying that the head, in quotation marks of course, the head is the x, so that would be x excuse me, x squared is equals to 4py. Should we add a negative? No. Why not? Because there's no negative sign. Now why am I calling it a head? It is just some silly example or way of memorizing it, but yeah, it works for me. I don't know, maybe it might work for you, but yeah, this is the x-axis, so that's x squared. This has a squared, this doesn't. That's why I'm calling it a head. Okay, and then why are we going with a one with a positive? It's because it is orienting upwards in the positive y direction, and not in the negative y direction. So yeah, that is that. So this here is what we have. Okay, now remember, when we're driving these equations, this x and this y are some points on the surface of the parabola. Let's not forget that. Now, we've been told, saying regarding this parabola, okay, it is 12 inches wide and then 8 inches deep. So, yeah, let's not forget that. So, let me just draw another one here. So, it looks something like this. Then this here is 12 altogether. Now, what is a half of 12? It is 6. So, this will be 6. And then this here will also be a what? A 6. Then how deep is it? It is deep by 6 inches. So starting from the vertex, so we didn't draw that nicely, but yeah, starting from let's see, starting from the vertex all the way up to that surface up there. Okay, this is 8 inches. So meaning the coordinates for this will be 6,8. So this here is our x, y, and always remember saying p in this equation. P is the foci. Just as we were discussing previously in the previous videos, this here is your parabola. Where would your P be located? Sorry, your foci. Your foci would be negative P, comma 0. To say negative x, comma 0. Here it would be P positive x, comma 0. Here this would be negative P, comma, this will be a 0, comma, negative P. And the same thing goes for the one at the top. So that is what we have. Okay, so this so this x will be the 6 and then the y will be the 8. Okay, so with that being done, we can just go back to our equation, which is x squared is equals to 4py. What is our x? Our x, as discussed, is 6 squared is equals to 4py. Remember, we're trying to find the foci, because all that they've said is what is the distance from the vertex to wherever that is to say the foci. Then what is our y? Our y would be 8. So it would be 6 times 6, which is 36. Then this would be 8 times 4, that would be 32p. Then we say over 32 over 32. So when we cancel out, this here will be p is equals to 36 divided by 32. So this is our foci. Of course, we can just simplify it, and when we do, we just see what are we going to say? So 2 in a 3, that would be a 1. 2 in a 6, excuse me. Anyway, come on guys, you know how to simplify this. So this here will be a 9 out of 8. So yeah, anyway, for the sake of everyone, 3 into itself 1, 3 remaining with the 1, that's for the remainder. 2 into 16, that is an 8, over 2 in here, that would be a 1, remainder 1, so that would be 2 into 12, that would be a 16. Then we say 2 into 18, that would be a 9, then 2 in here, that would be an 8, so that is 9 over 8. So yeah, that is the final answer. That is the distance from the vertex to the point P, which is the foci. So it looks something like this, where P is what we found. Now, what if you're told to find the latus rectum, the distance of this latus rectum? Remember, from here to here, this is what? P. Then from here to here, it is 2P. Then as for the directrix, it is located negative P downwards. So this here would be P, P. So in other words, this whole distance would be 2P as well. This is what we discussed when coming up with the formulas. We said this distance here is the same as this distance here. So to find the length of the latus rectum, it is just going to be 2P. So that would be the distance from here to here. Then the distance for the whole thing, it would be 2P plus 2P. So that's that. Please don't forget to subscribe. You can share this video to your friends if you would like them to do well in mathematics. And of course, if you are good friends with them. Thanks for watching.